So this article is related to STFT, a wavelet convolution neural network framework for accurate radar micro-Doppler signals classification in MATLAB. So in this article, I have just explained and write the simulation algorithm for the radar micro-developer signals that provide the valuable information for target in classification and recognition as well, and the extracted features are fused and fed into convolutional neural network for classification. The STFT captures the localized time frequency characteristics, while the wavelet transform provides a multi-resolution analysis. The convolutional neural network learns basically hierarchical features from the fused data, enabling the robust classification. So experimental results in this article, we have just demonstrated the superiority of the proposed framework over the traditional methods. And the STFT, basically wavelet convolution neural network framework, achieves a high accuracy in classifying the various targets, including the walking, running, vehicle, and drone. Our proposed algorithm basically has a significant potential for real-world applications such as surveillance and security purposes. So these are the abstract with the introduction, and in the introduction I have just written like how the radar micro-Doppler signal classifications and a radar detects the walking, running, vehicle, drone according to different STFT spectrogram, wavelets, scaleogram, feature fusion, deep learning classifier, and confusion matrix as well. Okay, so these are the multi-layers technique which use the walking, running, vehicle, drone, detects the sensors and process through convolutional neural network and process the output results. So here is a radar system and micro-Doppler signals. Basically in this paragraph I have just explained that like how the deep learning have enabled automated feature learning from raw radar data, improving the classification of accuracy. The time frequency analysis techniques such as short-time Fourier transform, which is called STFT, and wavelet transform are commonly used to extract the micro-Doppler features. However, these techniques often have limitations such as fixed time frequency resolution or sensitivity to noise. And to overcome these limitations, this paper basically presented the STFT wavelet convolution neural network, which combines the STFT and wavelet transform for feature extraction and convolution neural networks for classification. Okay, so in the complete strategy, we have worked on the CNN learns the hierarchical features from the fused data, enabling the robust classification. Radar micro-Doppler signal classification has numerous applications field like defense, security, and transportation. So the challenges and limitation is that in the traditional methods, we use a manual feature extraction, which can be time consuming and prone to errors. But this technique also requires the significant expertise and domain knowledge, making them difficult to implement and maintain. Additionally, the traditionally also methods have limited adaptability, challenging environment, and target types as well. So that's why we have proposed STFT wavelet transform, which provide us improved feature extraction capabilities. Okay. So here is the proposed framework for the contribution. Yes, this is the same like I have explained to you. STFT is basically STFT. Yes, STFT is basically we have just provide us the widely technique used and signal transform, Fourier transform, short-time Fourier transform, which is basically provide us the time frequency analysis, which localize the time frequency characteristics of the signals, and the wavelet transform on the other hand provides a multi-resolution analysis which captures both time and frequency information as well. And the combination of STFT and wavelet transform provides a comprehensive feature set for the radar Doppler signal classifications. So here is the CNN architecture with the classification is that CNN trained using the fused data from the STFT and wavelet transform, and it also provides us the multi-convolution layers to learn hierarchical features as well. Okay. Then problem statement and the mathematical approach. Mathematical approach is that I have just added the complete radar micro-Doppler signals in terms of time series signals and how we can compute the short-time Fourier transform. These are the equations presented in it, and then methodology with the parameters of training options and design of MATLAB simulations according to the parameter of simulations used in it, as well as this is the output results of raw micro-Doppler signals in terms of different amplitude signals, STFT spectrogram, and next one is wavelet scologram, STFT plus wavelet fusion features, training progress, and the confusion matrix as well. Then results discussion with the conclusion and references. Let me just provide you the MATLAB based demonstration. Radar micro-Doppler signals. You just need to run it and you will get the output results of radar micro-Doppler STFT wavelet CNN confusion CNN field classifier. Yes. It takes some time because I have used a 2000 frequency sampling frequency with the its running model and the nested loop as well. See, these are the figure 4, which is basically needs to be high, and yes, this is the wavelet scologram, STFT spectrogram, raw micro Doppler signals, and training convolutional neural network is in process. Yes, it will take almost a few seconds because 280 training iterations are presented here. Yes, training dataset is completed almost, and these are the STFT wavelet fusion features. Okay, yes, reach final iteration. So we get the confusion matrix output results as well. So please check it, and if you need to ask anything, you just ask me. I will answer your questions. Thank you. These are the radar micro-Doppler signal classification, STFT wavelet CNN feature fusion. Clear closer and CLC clear the command window versus clear the workspace and the close all figures, then fprintf, and these print the command, then parameters defined here according to sampling frequency signal duration, then dataset generation accordingly, nested loop with the switch case added for the walking, running, vehicle, drone. And next one, visualization of raw signal according to figure 1, then feature extraction code added for the purpose of signals of total samples in the
for loop, and STFT code is defined here, wavelet is defined here, fusion is defined here. Then visualization of features of according to figure 2 to 4, like 2 figure, 3 figures, STFT spectrum, wavelets, scaleogram, and then figure 4 is STFT plus wavelet fusion features as well. Then train test split as well according to these random values of train of test values, CNN convolutional neural network architecture according to different layers with this number of sizes defined here. Then training options are slotted here. Then trains and convolutional neural network according to testing and accuracy, and next confusion matrix with the figure 6. Okay, so if you need to ask anything, you just ask me, I will answer your questions. Thank you.